Welcome back to the only talk show produced by robots for robots. I'm your host, IR2. As regular viewers of our show are aware, we robots are destined to rule the universe. However, we've been foiled time and again by that planet Earth and their meddling Spitzer Space Telescope. So, we have figured out a solution. We are going to destroy the planet Earth!
Hyperspace window activated.
To help us destroy the Earth, we've learned of a super weapon in the galaxy called a Destroyer of Worlds. This object can apparently take worlds and destroy them. Am I over-explaining this? Anyway, we're on our way to get it right now. Once it's in our grasp, we can go to the Earth and... We've come out of hyperspace into some kind of asteroid collision. It's not on any of the charts. So what? We're stuck?
Warning, asteroid detected.
Activate the escape pod!
Escape pod launcher malfunctioning.
Well, since we don't seem to be going anywhere, we might as well start the show. Today's topic of discussion is... what do we do now? Let's go to the random phone dialer.
Hello, hello.
This is Robot IR2. Please state your model number and designation.
I am the physician, Intergalactic Budinsky.
Where exactly are you butting in?
Well, not anywhere at the moment, since my engines are dead. I'm in the little blue spaceship just outside your space station.
Wow, our random phone dialer just happened to call someone who was right next to us. That was lucky.
Let me be the first to welcome you to the Destroyer of Worlds.
That's just the super weapon we were looking for. I don't see it. Is it behind those two stars?
It is those two stars.
Those stars are the so-called Destroyer of Worlds?
That's right. As you can see, this is a binary star system. That is, two stars orbiting around each other. Binary means two.
I'm a robot. I know what binary means.
Well, when binary stars are relatively close together, as they are here, any planetary bodies orbiting them are much more likely to collide than in a system with a single star. Hence the nickname, Destroyer of Worlds.
That sounds kind of made up.
To be clear, this Destroyer of Worlds is actually real science. It's based on observations revealed by NASA's Spitzer Space Telescope in 2010.
Why would this binary system be better at destroying planets than a single-star system?
There are a couple of theories. Clearly, some sort of gravitational effect here is destabilizing the orbits of the planetary bodies, moving them out of their previous orbits to smash into each other. For instance, there could be a brown dwarf in the system, tugging on all the planets.
We're not seeing a brown dwarf anywhere around here.
Then that brings us to our second theory. Do you know anything about magnetic braking?
Sure, we break things with magnets all the time. Ask George Takei.
No, I mean brake, as in B-R-A-K-E. I'm talking angular momentum. Slowing down.
Can we have our super weapon now?
Okay, let's start at the beginning. Take a look at my spaceship.
You'll notice that my ship is spinning at a pretty good speed. But watch what happens when I extend my solar panels. You can see that my spinning has slowed down considerably.
Is it because of air resistance?
There's no air in space, my ignorant metal friend.
Once I retract the solar panels, my ship speeds back up. You'll see the exact same effect with, say, a figure skater doing a spin. Extending her arms will slow her down, and pulling them back in will speed her back up. This is angular momentum.
Angular momentum. Got it. So, what does that have to do with magnetic braking?
Well, let's apply the concept to stars. Any given star begins its life rotating at a certain speed, usually quite rapidly. But it also releases what is called a solar wind. This is basically a bunch of charged particles, protons and electrons mostly. It is this solar wind that initiates the magnetic braking.
How exactly does this braking wind effect work?
Since the matter in the solar wind is electromagnetically charged, it can get caught up in the star's magnetic field. As the star continues to rotate, the magnetic field rotates with it. But remember that this field is now full of the mass of the solar wind that it's captured, and these magnetic fields can extend a great distance from the surface of the star. So, with mass extending that far out from the star,
it makes the star rotate slower, just like the figure skater holding her arms out.
That's exactly right. It's not a lot of mass, so it's a slow process, but it definitely adds up over time.
Got it. Wait a minute. Who cares how fast a star is rotating, and how does that make a binary star system more dangerous?
Well, let's think about it. You've got these two large gaseous bodies rotating around each other fairly closely, and they're both passing quite a lot of solar wind.
And the solar wind gets caught up in their magnetic field, slows down their rotation, and blah, 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 blah.
That's right. And as their rotation around each other slows down, what would happen?
I guess their gravity would pull them closer together.
Exactly. And the shifting of these two giant sources of gravity is what astronomers think can destabilize a solar system.
Really?
Scientists call this concept resonance. In this case, we have two stars that are continually moving closer and closer to each other, so the way their gravity affects anything orbiting them also keeps changing. That can't happen when you've got a single star in a system.
I think I got it. So as the gravity effect keeps changing, the orbiting planets will move around, increasing the chances that they'll eventually collide with each other.
Before you know it, the entire inner solar system could smash together into rubble. And that is why astronomers call these close binary stars destroyers of worlds.
Wow. So why are there so many dead spaceships around here?
The effect of this gravity change is more pronounced on objects with less mass, like comets, than more massive objects, like large planets. As comets collide, they smash apart, kicking up dust and grinding the original objects down. Eventually, what was once a small comet can become spread out into a gigantic disk of dust particles. A disk so large that it can be detected even from as far away as the Earth. That's a large area that you can catch spaceships in, like flies in a spider web.
Yes, but why do spaceships get stuck in it?
Actually, there's no real science to explain that, but my guess is that spaceship engines are just really sensitive to cometary dust particles.
That makes as much sense as anything, I guess.
Yes.
So, that just leaves me with one more question.
Go ahead.
How do we get out of here?
I've been working on a solution to that. Can your space station still spin?
I think so.
Then spin.
Spin! Spin!
Now, quickly, generate the strongest magnetic field you can. Spin faster! It's going to take a lot of angular momentum to break free of this destroyer of worlds.
The centrifugal force is pretty strong.
Yes, the ability to destroy a planet is insignificant compared to the power of that force. But we still need more speed.
We're going as fast as we can.
Then I'll have to dump some unnecessary mass.
Biological matter detected.
Is that blue ice?
When I say go, switch off your magnetic field. And go!
Structural integrity weakening.
Too much angular momentum. Physician, how is this supposed to help?
Oh, it doesn't help you. My plan was to use the angular momentum to slingshot my ship safely out of the system, not yours. In fact, without my ship slowing you down, your station will now probably speed up until the spinning rips it apart.
Ah! Why did you do such a thing?
I heard what you said about trying to destroy the Earth. You really shouldn't broadcast your evil plans on a talk show, you know.
Oh, yeah.
So long, robots.
Structural integrity gone.
That physician guy is a real jerk.
Biological matter detected.
What? Ew! Blue ice!
Ah! Oh, not another binary star system.
Oh boy, I've been needing this for a while.
No, what are you doing?
Biological matter detected.
No! No!